Welcome back. For today's deep dive, we're going to get into something you interact with every single day, but maybe in a way you've never really considered.
We're talking about mathematics, numbers, sets, functions, all of it.
Exactly. And the core question is a really strange one when you first hear it. Are numbers real? Do they exist out there objectively, like a planet or, this chair?
That's the heart of it. This is mathematical Platonism. And our mission today is to really get to grips with what that means and then look at the, frankly, devastating challenges it faces from philosophy.
Okay, let's start with the basics then. If I say I'm a mathematical Platonist, what am I actually signing up for? What do I have to believe?
You're signing up for three pretty bold claims. First is existence. Simple enough. Mathematical objects exist.
Okay.
Second, abstractness. They aren't physical, they're not in space or time, and they're causal, meaning they can't cause anything to happen in the physical world.
Right, the number 7 can't push me down the stairs.
Exactly. And third, and this is maybe the most important one, independence. Their existence has nothing to do with us, with our minds, our language, anything.
So if every thinking being in the universe just blinked out of existence tomorrow,
Vanish.
the truth that 7 plus 5 equals 12 would still be a fact. It would just be out there.
Precisely. And you can see why the stakes are so high. If that's true, it really puts pressure on physicalism, the idea that reality is only physical stuff. And it creates this huge, huge headache for how we know things. I mean, how do you know about something that can't interact with you at all?
And yet, this idea, this Platonism, is basically the default setting for most working mathematicians, right? They call it working realism.
It is, because it gives you a license to do so much. If mathematical reality is just out there waiting to be discovered, then you can justify using really powerful tools, things like classical logic or non-constructive proofs.
Okay, break that down for us. A non-constructive proof, what is that?
It means you can prove that something must exist, say a number with a specific weird property, without ever actually having to find it or write it down. You just prove its existence is a necessary truth.
That's fascinating. It fuels this idea, this Hilbertian optimism, that every problem has an answer already written down somewhere. We just haven't figured out how to read it yet.
That's the belief, ultimate faith in objective truth.
But faith, as we know, runs into trouble in philosophy. So let's get to the main event. Paul Ben-Asaraf's dilemma. It starts with this metaphysical problem, right? The identification problem.
Yes, and it's so clever. Ben-Asaraf just asks, okay, you say numbers are real, objective things, fine. Which things are they?
What do you mean, which things? The number 3 is the number 3.
Is it? See, the foundations of arithmetic, the natural numbers, can be built out of pure set theory in an infinite number of different ways.
And all these ways work. They all give you the right answers for your sums.
Perfectly. But here's the problem for the Platonist. These different foundations describe fundamentally different objects.
Can you give us a concrete example?
Sure. The classic one is building numbers out of sets. In one system, the Zermelo way, the number 3 is basically a set inside another set. It's about the levels of nesting.
Okay.
But in another, more common system, the von Neumann way, the number 3 is defined as the set that literally contains the numbers 0, 1, and 2.
So one's about hierarchy, the other is about contents.
You've got it. And the famous analogy is about two boys, Ernie and Johnny. Ernie learns the von Neumann way, and Johnny learns the Zermelo way. Both are geniuses at arithmetic.
They can do any calculation.
Any calculation. But one day, Ernie realizes, hey, based on my definition, the number 1 is a member of the set that is the number 3. It's a logical truth for him.
That's for Johnny.
For Johnny, who learned the nesting doll version, that statement is just outright false. 1 is not a member of 3. It makes no sense in his system.
Wow. So they agree on every single mathematical property of the number 3, that
Yeah.
it's prime, that it's 1 plus 2, but they fundamentally disagree on what the object is.
And that's Ben-Asaraf's killer point. If math itself doesn't care which one is the real 3, then the Platonists claim that numbers have a single, fixed, real identity just. It collapses. The only properties that seem to matter are structural.
The relationships, like being the number after 2 or half of 6.
Exactly. The object itself seems to be irrelevant, which pushes you toward an alternative idea, structuralism, where maybe numbers are just positions in a structure, not objects at all.
Okay, but that feels like it just kicks the can down the road. Because you still have the other, maybe bigger problem.
Epistemological problem, the access problem.
Right. Even if it's a structure, it's still an abstract structure.
Yeah.
How do we physical beings trapped in space-time, ever get reliable knowledge about something that's totally causally cut off from us?
This is the hurdle. With a physical object like a desk, light bounces off it, hits your eye, your brain processes it. There's a causal story.
But there's no causal story for the number 7. It can't send you a signal.
No signal at all. And this challenge is so profound that the strongest modern defense of Platonism has to completely change tack. It moves away from intuition and toward, well, pragmatism.
This is the indispensability argument from Quine and Putnam.
That's the one. And it's a really different kind of argument. It's externalist. It ties math to our best empirical science.
So how does it work?
It's quite simple, really. Premise 1. You can't do our best science physics, for example, without using mathematics. It's indispensable. The law of universal gravitation needs numbers and functions.
Okay, that seems undeniable.
Premise 2. We ought to believe our best scientific theories are, true, or at least our best approximation of truth. Conclusion. Therefore, we ought to believe in the existence of the mathematical objects that those theories depend on.
So if you accept that gravity is a real thing, and the formula for gravity is inseparable from the numbers in it, then you're forced to accept that the numbers are real too.
Or else you're saying our best science is based on a fiction. Putnam's famous line was that if you call the math a fiction, the law of gravitation becomes theology, in the worst sense of the word.
Wait a minute, though. Does that really work? Just because something is a useful concept in a theory, does that mean it has to exist? I mean, economics talks about the average consumer, but nobody thinks there's an actual person out there who is the average consumer.
That is a brilliant objection, and it's at the core of the whole debate. The response from a Quinian Platonist would be that mathematical objects are different. They aren't just statistical constructs, they are part of the fundamental logical structure of the physical claim itself. But you're right to be skeptical. This version of Platonism is strange. It makes mathematical knowledge empirical, fallible, and subject to revision, just like science.
So we've got this fork in the road. One path is this new pragmatic Platonism tied to science. What's the other way out?
The other path is to reject Platonism altogether, and the main alternative here is nominalism, which just flat out denies that mathematical things exist at all.
Before we go full nominalist, what about that middle ground? Gödel had a different take, didn't he? A return to a more traditional intuition-based view.
He did. Gödel was not at all happy with tying math's existence to physics. For him, the justification was internal. He talked about mathematical intuition.
Which sounds a little mystical.
It does, but he was very specific. He called it propositional intuition. It's not a hunch. It's a kind of deep conceptual reflection. You think so clearly and rigorously about the concept of a set, for instance, that you come to see certain axioms about it as self-evidently true.
So for Gödel, the truth of math emerges from its own internal coherence and meaning. We don't need science to vouch for it.
Exactly. Its reality is revealed through rigorous thought, not physical experiment. But now let's pivot to the full-blown counterattack. The nominalist view, led by Hartree-Field.
And Field's big project is to directly refute that indispensability argument we just talked about.
Right. He takes a fictionalist view. He says mathematical theories aren't true. They're useful fictions.
Which brings us back to the magic question. If it's a fiction, why on earth is it so good at describing reality?
Field's answer is one word: conservativeness.
Conservativeness.
He argues that mathematics is just a reliable, but ultimately dispensable instrument for deduction. It's like a calculator.
Okay, explain that.
If you start with some purely physical nominalist statements, facts about objects, positions, velocities, and you plug them into the mathematical machine, you get a physical nominalist conclusion.
Like where a cannonball will land.
Exactly. And Field's key claim is that math is conservative, because that conclusion you reach could have been reached without the math, just through a much, much, much longer chain of pure logic.
So the math adds no new physical information. It's just a shortcut. A brilliant, powerful shortcut, but a shortcut nonetheless.
That's the argument. And if that's true, then its utility doesn't force you to believe it's true. Unlike, say, electrons. Believing in electrons allows you to predict genuinely new things you couldn't otherwise. Math, for Field, doesn't do that.
So the whole nominalist project is basically to try and rewrite science, to show that the numbers were never actually necessary in the first place, just convenient.
That's the goal, to show it's all dispensable.
So this philosophical divide must have real consequences for how math is actually done, right? Especially for the really high level unsolved problems.
Oh, absolutely. Take something like the continuum hypothesis, which is about the size of different types of infinity. It's famously undecidable in our current system of mathematics.
So if I'm a Platonist, a Gödelian Platonist, how do I approach that?
You believe there is a right answer. It's out there in the objective mathematical reality. Your job is to discover it. So you're motivated to search for new, self-evident axioms that might finally settle the question one way or the other. The truth exists, you just need to find the key.
And if I'm a nominalist, following Hartree Field?
You might just shrug. You could say there is no single right answer. Set theory with the continuum hypothesis is one useful tool. Set theory with the denial of the continuum hypothesis is another useful tool. As long as both are conservative and help you do physics, they're equally valid.
So for the Platonist, math is discovery. For the nominalist, it's about creating a powerful tool.
That's a perfect summary. One sees math as confirming existence through necessity. The other sees math as being so logically transparent that it eliminates the need for that existence.
A battle between stumbling upon the truth and inventing a tool to navigate the world.
It is. And maybe a final thought for you to chew on. Think about infinity. Most mathematicians treat the infinity of the counting numbers as an actual infinity, a complete, finished thing.
Right, yeah, it was all there.
But some philosophers argue that maybe some infinities, like the hierarchy of all possible sets, are only potential. That is, no matter how many you have, you can always create one more. The collection is never truly finished.
So it's always in a state of becoming.
Exactly. So what if that's true? What if some mathematical objects have this strange potential form of existence? Does that blur the line we've been talking about? Does that make mathematics something that is neither purely discovered or purely invented, but maybe something in between? What would that do to the whole Platonist picture? Something to think about.